Hello, good morning. Crystal field theory applied to tetragonal, distorted octahedral, and square planar complex. The distorted octahedral, or commonly called tetrahedron geometry, in a complex is resolved when the two trans lesions lying on the z-axis of the octahedral complex are moved either towards or away from the central metal ions. When the two trans lesions lying on the z-axis of octahedral complex are moved either towards or away from the central metal ions. When the two lesions moved away, the lesions lying on the xy plane tend to approach the central ion are more closely, which cause the electrons in the d orbitals along the z-axis dz square, dxz, and dyz experience the least repulsion from the lesions, whereas those in the xy plane, dxy and dx square experience relatively greater repulsion. The distorted octahedral, or commonly called tetrahedron geometry in a complex, is resolved when the two trans lesions lying on the z-axis of the octahedral complex are moved either towards or away from the central metal ions. When the two lesions moved away, the lesions lying on the xy plane tend to approach the central ion more closely, which cause the electrons in d orbitals along the z-axis, dz square, dxz, and dyz experience the less repulsion from the lesions, whereas those in xy plane, dxy and dx square, y square experience relatively greater repulsion. Hence, the energy order of various d orbitals on tetragonal geometry is dyz, dxz, dxy, dz square, dx square. Similarly, when the trans lesions are completely removed, the octahedral complex, the square planar geometry is formed. As a result, the electrons in d orbitals along the z-axis further decrease in their energy, but the electrons along xy plane, dx square, y square, dxy experience more repulsion and hence increase the energy level further, hence the energy order of various d orbitals on square planar geometry is dyz equal to dxz, dz square, dxy, dx square, y square. Figure crystal field splitting in octahedral, tetrahedral, and square planar geometry. Degenerate d orbitals in ground state, degenerate d orbitals lesion field excited field, octahedral, tetrahedral. The crystal field splitting in square planar complex is represented by ds square planar and is the total of delta 1, delta 2, delta 3, delta sp equal to delta 1, delta 2 plus delta 3. This is the always larger than delta naught. It is concluded that the splitting energies for octahedral, tetrahedral, and square planar complexes varies with each other. Generally, the relative order of splitting energy is delta Sp, delta A naught, and delta T. Delta T equal to 4 over 9 delta naught.